x minus 3 over x squared minus 5x plus 6. And you copy in factory form the factorization x minus 3, x minus 2. I did that part here. You can see that the factor x minus 3 is cancelled. And the answer is 1 over nothing, 1, x minus 2. And this I want to call G, pero G1 in x. Because this is a family of the original, but it's not exactly the same. So the factor que is gone after your simplification is a whole. So at x equal 3, the function, the original function it has a whole. At x equal 3, equal to, sorry, is the remainder part, that the remainder factor and the denominator correspond with the asymptote. It is a vertical asymptote. So the first job you should do always when you analyze rational expression is express in factory form, simplification, the common factor, and the new expression is equivalent to the original, but not 100%, because the graph of this include whole, and the graph of this do not include. To see more clear, because one picture is much better than 1,000 word and 1,000 equation. Let me try to show you in Desmos the graph of this. Okay, I go back to Desmos now. Machine Desmos. Okay. You see Desmos now? Do you see Desmos? Yes. Okay, we are doing now example 2. Look at that. Example 2. Okay, I copy here. I copy the original function, of course. I copy x equal to, que corresponde with the vertical asymptote. Remember the definition for the vertical asymptote is the curve approach it, pero never touch. Okay? Pero approach it to infinity value, infinity positive or infinity negative in this case. And the whole is here in 3. Let me see, let me make it zoom. This is 1, this is 2, this is 3, this is 4. And 2, we have vertical asymptote. And 3, we have whole. Any question? Any question? No? Super. We are the best. Eh? We are the best or no? We are or no?
Of course, we're the best.
Okay. Let me try to discussing now a new part. This is complicated, but don't worry. This is just theoretical. But I promise that when they finish the theoretical part, I bring for you what is the guideline for solving this kind of problem. And I have 3 fantastic problems to illustrate every possibility. And also in the review packet, we study more. So we study one thing now that's called a horizontal. Horizontal asymptote.
You're still in Desmos.
Oh, sorry. There you go. Thank you. You saved my life. Now, it's okay? It's okay. It's a board? It's a whiteboard?
Yes.
Yes. Okay, now let's see horizontal. Horizontal asymptote is similar to the end behavior. Similar. Let me try to explain. End behavior, guy, is when the x approaches, no equal approach. This arrow indicates approach. Approach means que si es approaching to 3 is 2.9 or 3.1, maybe to the right or to the left, to positive infinity or negative infinity. So as the value for the my function is rational. Remember P divided by Q, to polynomial, no? but I want to investigate what happened, at what value the function approached to one value. I don't know, let me call B. And this value B is when the x approaches to positive infinity or negative infinity in both directions. So this is my real number. This is positive infinity. This is x. This is negative infinity. And the y value for this function approaches to one value gets B. Let me try to understand. Okay, one roughly sketch to understand horizontal asymptote. Suppose okay, we have a curve like that. Okay, wait. This is the horizontal asymptote. Normally the asymptote is auxiliary line. Auxiliary line que normally we draw using dotted line. Suppose those is one example, no? We see in detail another more in detail, but for example, suppose like something like that. Ooh, this curve, blue curve, is the rational function, maybe, no? Approach it when you approach it to positive infinity or negative infinity, the curve approach it but never touch. Well, never, no, sometimes touch. Let's see, one is a touch and one don't touch. Suppose another case like that. Because in this moment, in this specific case I try to do, we have maybe a vertical asymptote here. But I don't care vertical because I know vertical. My goal is horizontal. Sometimes another case is like that. In this case, yes, touch. And this is important point. I need to find. This point is important to find. This is a very roughly idea about horizontal. Entonces I want to explain the rule to determine si we have or no horizontal and what is the regular case, what is the special case. Suppose this example. Example 3, no? Suppose a function f of x equal 7x squared plus 2x over 4x squared minus 3. My first question is, we have horizontal asymptote, yes or no? And the second question, this is my first. The second is, where is located this horizontal axis? Okay? So what is the rule? The rule is clear. If the degree of the polynomial B, the polynomial B is the top part. Top is P. I call P always. Is equal the degree of polynomial Q. The polynomial Q is bottom. A Q. That implies then we have horizontal. Así degree 2, in this case the degree is 2. Degree of this polynomial is 2. Degree of this polynomial is 2. Same degree, yes we have. The answer of this question is yes. Otherwise, let's see after. Because we have a special case. But in general, si the degree is the same degree, equal. Another example is suppose 3, 3 or 4, 4. Yes, the answer is yes, we have. Where is the second question? Where is located the horizontals? The analysis is very straightforward. Look, you analyze in the top, what is the dominant term? Dominant. The dominant is this guy. Why is dominant? Because it's the term increasing faster. So this is a square function increasing faster than linear. Linear is degree 1. So the dominant is in the top 7x squared. And the dominant in the bottom is 4. for the same reason. You take always you take the term que contain higher exponent, and this is the dominant. Entonces you see, wow, look at that. X squared cancel and stay alive only 7/4. The horizontal asymptote, que es the horizontal line, que any horizontal line, you know, the equation is y equal any number. In this case is 7/4. Okay? Do you understand the idea or a little bit confusing? Confusing?
I don't understand though y equals any number.
Good. Okay. I suppose, Miss, you know in algebra, elementary algebra, y, for example, equal to is a horizontal line. Yes or no? Do you remember or you don't remember?
Yes, I remember. I know.
Okay.
Yes. Okay.
The thing I tried to explain was the formula, the equation, y equals 7/4 is also a horizontal line. That this is a horizontal asymptote.
Okay, now I understand. Okay, thank you.
Mucho bueno. Okay, let's see example. Let me see if you understand very well or no. I bring two examples. This example, what number is example? Bueno, it doesn't matter. It's a complementary example. Eso no importa. Pero es a complementary example. Suppose another example que es the function h of x is equal 8x squared plus 9x minus 5 in the top divided by 2x squared plus 1. Again, the two important questions. Question number one, we have or we have no? We have or we have no? Horizontal asymptote. Question. Second, where? Come on, who helped me?
Yes, we have one.
Okay, yes. Why? I need to understand the reason. Why? Because
the degree, they both have the same x2 and x2.
Absolutely. Degree is the same. My second question, where? Where? Y equals something. Why not? A over 2. A over 2 y A over 2, I know que 4, ¿no? Ok, entonces the horizontal asymptote es at y, equal 4. Super. One more example, a little bit confusing, very confusing. Suppose the function p of x is equal x squared.
And so the answer to the above where would be y equals 4, or the answer would be 4?
Yes, positive, miss. The answer of where is y equal 4.
Okay, thank you.
It was the ratio between this number and this number. Remember,
No,
this is.
I understood that part. I just wanted to make sure I knew how to answer it correctly. Thank you.
Dominant term. Suppose this example, p of x is equal to x squared plus 7 divided by 11 minus x squared. Again, number one, we have or no? Vertical. Horizontal asymptote, so. And number two, where? Okay, help me. We have or no? No, yes. No, yes. It's easy. It's a yes or no question.
Yes.
Yes. Why?
Because you can rewrite the bottom formula x squared, negative x squared minus plus 11, so you still have 2x squares.
Very well. She say, can you rewrite the bottom part like that? And you can see that the degree is the same, therefore the answer is yes. My question is where? Now, y equals something. What is the line que represent the horizontal asymptote in this rational function? What is the dominant?
-1.
-1. It's the answer. -1. The answer. Where come from this -1? Was the ratio +1 and -1. So you take the dominant. The dominant is obvious que es the term que contain higher degree. This is negligible. This is negligible. This is nothing. Okay, when the x approaches to infinity, infinity means 1 million, 10 million, infinity, a huge number. When you plug it in here, this is the dominant. 7 is nothing. It's negligible. 11 is nothing, negligible. And not always when there's a number. Here is negligible, and this is negligible, and this is negligible. Always you take the higher, the term can contain higher response. This is dominant idea. Because it's the aim behavior. Super. Super. But I have bad news. Bad news. And the bad news is that when the degree is the same, yes, we have horizontal, but we have another special horizontal asymptote. And this happens when the degree, suppose when the degree, that if degree of P of Q, doesn't matter, this is statement you can change. It's greater than degree of P. Okay, one, and then, yes, we have horizontal asymptote, but special horizontal asymptote. Why is it special? Because it's always at 0, y equals 0. Let me try to understand using one elementary example. Suppose this function, f of x equal 5 divided by 4x squared plus 9. Wow. In this case, I can analyze. This is P. P contains degree 0 because it's just a constant. X is missing degree 0. And it's a Q. And this is degree 2. Then degree of the bottom, Q, is greater than degree. Therefore, yes, we have horizontal asymptote at y equals 0 always. Y equals 0. Let me try to understand why is 0. Okay. This is the end behavior. Look at that. End behavior of 5 is 5. Because 5 is a constant. 5 stays the same. But this is negligible. This 9 is 4x squared. And what happened when the n, when x approaches to infinity, positive or negative? No, let me put positive. See, negative is the same because it's positive or negative. When you square, become positive. So this is 5 over 4 multiplication by, 1 million. So this is 1 million. This is 4 million. And 5 divided by 4 million is obvious que es a very, very, very small number, right? Decimal 0.000 is a small approach to 0. This is the idea of the horizontal asymptote. Make sense or you need more clear explanation? Why is 0? Okay, let me explain. Suppose 1 over 10. 1 over 10 is 0.1. I put in my calculator. Suppose que I increasing forever this 10. No 10, it's 100. It's 0.01. Ooh, what happened with the answer? The answer decreasing when the denominator increasing. Suppose 1,000 is 0.001 and so on. And you see, yes, this number increasing forever, infinity here, this approach to 0. Okay, this number is 0.1, 0.01 is smaller, 0.1 is smaller, and when you increase in forever, the denominator and the numerator is a constant, or no constant, it's another polynomial of the lower degree, then the asymptote is 0. This is clear, confusing, complicated. I promise in the example you see very, very well. I review this concept again. Let me stop and summarize. When we have Horizontal asymptote. I know we have in two cases. Case one is the ordinary case, and case two is special, no? When the degree of P is equal the degree of Q, oh yes, perfect. We have, yes. Special is when the degree of Q is greater than degree of P. Yes, it's special at Y0. And this is at Y equal the ratio between the coefficients in front, the higher degree, suppose 20, and this is 5, x to the 20. It's the same, no? 20, 20, 20 is cancelled, U is to 5. Y equal 4. Everyone follow me so far? Everyone understand very well this or no?
Yes.
Okay, good. Okay, the only participation is you, miss? Everyone understand? Using the chat to say yes or no?
Yes.
Okay. Okay, let me complement this idea for the horizontal. We almost finished horizontal, but we don't finish one more idea. It is something like that. Look, it's determined where a graph crosses a horizontal. Okay, because sometimes happen. Sometimes, no, not always. Sometimes the graph, suppose this is the graph, this is my rectangular coordinate system, x, y. Suppose that this is my horizontal asymptote. And sometimes happen that the graph touch here, but touch one time, not two times, and never approach it, but never close. This is continue forever like that, but never touch anymore. So this is important point. Determine this, and you need to verification if my graph, my function f of x, crossed or not the horizon. So I bring one example to illustrate very well this idea. Look, suppose the function like that. Suppose the function I want to call f of x equal 8 x squared plus 9 x minus 5 divided by 2 x squared plus. Now again, my two traditional questions. We have or no? Yes or no? Yes. Okay. What are I need to explain the reason. And the test, you say yes, yes, and you explain reason. And the test online, no. But in the test on paper, yes. Because the degree is 2 here. Look at that. And the degree here is 2. And the rest is completely negligible to effect of the horizontal asymptote. You remember is synonymous, similar to the aim behavior. Those where what value is located this horizontal asymptote? What value? Y equals something. Y equal what? Hey, horizontal asymptote. Where?
4.
4.
Y equals 4.
Y equals 4. Que was the division 8 and 2, no? Okay, super. Now, you know that. The new thing is verification at what value, at what x value corresponded this if exists. Because maybe do not exist. Maybe yes, maybe no. I am not sure. I need to verification. I need to prove, mathematical proof. But it's easy. You take the original equation. Look at that. You take the original equation. You take the original equation, the original function, and you enforce it to be equal 4. When you solve this equation, see you have solution, this is the point we are looking for. sometimes happen, this equation have no solutions. If we have no solution, it's because the graph, the blue curve, never cross the horizontal in this case. Okay, but in this case, I found one example that yes, we have solution and super easy to manipulate this equation because you can consider like a proportion and you apply cross multiplication. You multiply top r times 1 like that. So says 8x squared plus 9x minus 5 times 1 stays the same. And multiplication this times 4, so 4 2x squared plus 1. You apply distributive property to remove the parenthesis. We have ax squared plus 4. Now you see, wow, let me copy the equation. X squared plus 9x minus 5 is equal 8x squared plus 4. If you want to solve for x, I suppose, in this moment, I suppose que es quadratic equation, but actually it's not quadratic equation, but I don't know. Entonces, I move everything to the left. With the opposite sign, no? And we combine like term. And you see, wow, ax squared cancel, disappear. It's not quadratic equation. Entonces 9x, and we combine like term, negative 5 and negative 4 together is negative 9. It's linear equation, super easy. I move one more time 9 to the right hand side. Finally, divided by 9 both sides, and the answer is 1. Yeah, I discovered that yes, they curve crossed the horizontal asymptote at x equal 1. By the way, if you want to express it like an ordered pair, the famous point that we are looking for is the point 1 comma something. 1 comma like a x comma y. What is the y value in this point? What is the y value? What is the y value? What is y value? Please. No
4.
idea?
4.
Exactly, 4. Que is the value of the asymptote? Y equal 4. Nice, very well. Okay. Do you understand very well this? I want to show you this example in Desmos. Okay. Okay, I prepare for you. Let me switch the screen. Share with another screen to see Desmos. See, switching to Desmos. There you go. Desmos. Do you see Desmos now? Now remember, this was example 2 that we see before. Now example 3. Look. I copy the function. I copy the look. I copy the function. I copy the horizontal asymptote, y equal 4. Normally, the style to do the graph of the horizontal, I prefer, not mandatory, but I prefer black color that you click here and you can see the palette of the color. No, I select black and dotted line. Good, I like that for the asymptote. And for the curve, I select any color. I click here, hold the mouse. I select blue, but maybe you like red or orange. Okay. Entonces you see, the most important is you see the curve in both directions, positive infinity and negative infinity. Look at that. Positive infinity, negative infinity. Approach it to 4. Let me make it zoom. And the famous point that we are looking for was 1,4. It's the point when or where the curve, the red curve, crossed only one time the horizontal. Done. Any question?
No.
No? Okay. Very, very well. Then move on to the board. Okay. 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 Next topic. Next topic. Next topic, no, it's the same, but inside the same, we continue working maybe today and next time, working in the rational function because it's very, very complicated. Now we have slant acid. Slant acid. So far, we studied vertical, we studied horizontal. In your moment, I summarize one more time what is the formula to find the vertical, what is the formula to find horizontal. And now slant, que es the last. I promise, slant. Slant is like oblique. It's like that. It's horizontal like that. Vertical is like that. 90 degree, 0 degree. And slant is using another angle. I don't know. Si goes up or goes down, depending the slope of this. So when you recognize that we have slant or no, well, okay, if the degree of the polynomial in the top, P, is greater than, pero greater than, let me write in English, greater than 1, is greater than 1, just 1, not 2, than the degree of Q, comma, then exists. Exists Islam. Okay? One example to understand this. Suppose this. Suppose this. Entonces immediately you see, wow, the degree of this polynomial is 2. Es P. And the degree is Q of this polynomial is 1. According to this idea, when the degree of the top is greater than 1, is 2, and degree of this is 1, 1 plus 1 is 2, so we have it. Okay? Remember, horizontal is different. Horizontal is with the same degree, or the degree of the bottom is greater than. But no 1, either value, degree, suppose degree 1 over degree 2. And degree 1 is equal to degree 2 is typical horizontal. Or degree 1, degree 2. When degree 2 is greater than degree 1, it's typical horizontal, pero special. Why is 0? But this is different. This is completely different. It's when the degree of the top is greater than 1, not 2. For example, another stupid example is suppose x cubic plus 2x plus 4 divided by x plus 1. Degree 3, degree 1, no. Así es degree 3 and degree 2, yes. Do you understand the idea? Okay, this is my first question. Identify when we have or no slant acid. Analyzing the degree of the polynomial in the top and the degree of the polynomial in the bottom. Now, my second question is, where is the slant acid? What is the formula? What is the equation for the slant acid? Well, we need to do long division or synthetic division, depending, no? In this case, in this specific example, we can do using synthetic division, but in this case, no, because remember, synthetic division is only possible when the degree of the denominator is 1. Degree 1, yes, scientific division. Degree 2, no, scientific division. Long division. And remember, scientific division is one shortcut of the scientific division. Either way, let's do it by long division and scientific division, but you see it's the same. Forget about this for a moment. This was the extra explanation. I focus in my example. Suppose long division. Okay, because, my first question was, yes, we have a slant. Why? Because I analyze the degree. Now I copy the dividend is x squared, 1. But when the 1 term is missing, you put in the format of the division, you put like that. In order to keep by column the organization for the division. Be careful of this. So you put 1 here is not totally wrong, but you need to be careful. This is x minus 1. And division. It's obvious que x here because x times x is x squared. I multiply this times this and this times this. It's negative 1, so it's negative x. Negative x. 1 negative. By subtracting, you change the sign. Boom, bang. Remember division. Division, you divide in elementary school, 5 divided by 2. You multiply 2 times to the 4, subtracting, you change the sign, is 1. Exactly the same we are doing algebra. Polynomial. Okay, now I can see that this is cancelled and this is 1x. Because 0 plus 1 is bring down 1 because I suppose that we have to continue, no? And you know that you have to continue when you finish, you stop. When the degree of this polynomial is smaller than this. This is degree 1, degree 1. No, we continue. Continue. We have to continue. Now it's obvious que es plus 1, no? It's plus 1 because 1 times x is x. And 1 times negative 1 is negative 1. By subtracting, change the sign. There is a cancel, and this is 2. Then. The answer for the second question is where is located the slant asymptote. You take this expression, the question part. Okay, the slant asymptote is y equal x plus 1. And you plot that. And you plot that. How you plot that? I don't care the rest. You plot like that. Look, when you are doing the rectangular coordinate system, now I want to see in decimals. This is x, this is y. You plot that line, que the y and the z is 1. I know that my line passes through this point and the slope is 1. Wrong, rise, and this is my slant asymptote. It corresponds with this equation. Okay? And this is part of the graph. You need to plot maybe vertical asymptote, see we have or no. Okay. Do you understand or no? Confusing. Long division. Hey. Do you follow me? Are you receiving?
Except for how you went to which direction you went.
What direction you
on the slant?
No, both directions. This is a line, miss. This is a line, and the line travel in both directions. It's infinity in both directions. Wait. Let me try to.
But why didn't it go the other way? Like X up to the left and down to the right. That's what I don't know.
Good. Let me try to do. The student can prefer synthetic division. We can do that using synthetic division, no? Long division is more general division. Is always possible. Synthetic shortcut is only possible when the divisor is degree 1, like this example. But suppose this case degree 2, no, it's mandatory doing by long division. But in this case, we can do by synthetic division. Synthetic division is easy because you copy the coefficients, it gets 1, 0, and 1. Okay, this is x squared, this is x1, and this is x0, no? We come back to the original, look at that. Original is x squared plus 1. So x, the term que contain degree 1 is missing, pero I consider it in the synthetic division, 0, missing. And you divide by 1 positive. Ooh, why positive? Because it's negative here. And you put the opposite side. And the long division, you change the sign several times. 1 time, 2 times, 3 times. In this case, I change the sign only 1 time. It's negative, it's positive. So always change the sign. Bring down 1. Multiplication, 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Is 2. 1 plus 1 is 2. This is the remainder. Remainder. It's exactly the same of this number. And the answer is x to the 0, x to the 1. It's x plus 1 equal y. This is the equation for the slang axis. Any question? Chewy, what the hell is that? The hexagon.
I understand the division. I just don't understand. I guess because it's a positive, that's why it's going up to the right versus crossing going up to the left. That's what I'm trying to figure out.
Well,
I don't know how to. I can't draw on your blackboard to show you what I'm talking about, but
no. Okay, what part you don't understand?
just okay. Your line, you have the line that crosses X, going from left bottom to right top, correct? Okay, so why isn't it going from right bottom to left top?
Okay, the reason is clear. Look, I suppose you remember the equation for the line is y equal mx plus b, no?
Oh, okay, that's right. Okay.
No. Let me finish. B is 1 in our specific example. And m is 1 also. Because m is a slope, is the ratio between right and wrong. Do you remember that or no?
Yes.
Okay, entonces si es 1, es because it's 1 and 1. The right is 1 positive and wrong is 1 positive. So from this point, this one is this one, I move wrong 1 and rise up because it's positive.
Okay, now I get it. Okay, thank you.
Okay, by the way, this example contain one slang asymptote. Yes, we have one. Add the formula, the equation y equal x plus 1. Okay, this is. Now we have another kind of asymptote. Of course we have vertical because you take down the polynomial in the denominator, is q equal x minus 1, and you put it equal to 0. Because at x equal 1, we have one vertical asymptote. So the conclusion of this example is well, we have one rational expression, degree 2 in the top, degree 1 in the bottom. You analyze the degree, you decide, yes, we have, because the degree of the top is greater than 1 degree of the bottom. And also you perform synthetic division or long division, depending on the example, and you take the answer of the synthetic division, so the quotient of the synthetic division to determine the slang asymptote equation. Slang asymptote equation. Always is the same. It's the equation for the line. So you can express it using slope in a set form, y equal mx plus b, and you plot that. But no. Let's do it in demo. Okay, I go to Desmos to understand much better this idea. Okay, Desmos here. Decimal here. Okay, here. Okay. Okay, decimal, do you see decimal? Okay, that was the previous example, no? Example 3, now example 4. Oh, look at that. In the example 4, the equation, the original equation was x squared plus 1 divided by x minus 2. And so we determined that we have one vertical asymptote at x equal 1. Okay, this. Look, it's this. This is vertical. Look, I want to flash it. You see the vertical? And the slant is this. And you see the curve, que I put in blue color, approach but never touch this house. More clear? Super clear? Like water or like milk? Crystal clear? Okay, let's see another example. Another example of determine the slant asymptote. It's clear now, look in the Desmos simulation. Sir, student, are you sleeping? No sleeping? Hey, where are you? Are you tired? We have 10 minutes, no? Or 11 minutes to finish. It's too much information in short time? Okay. Come back. No. Okay, cancel. Okay. There you go. Whiteboard. Good. Okay. Who say that? Who is SA? SA is identification name. I need to be familiar with the name, guys. Somebody remember record the video because I always forgot. I don't know why I forgot. Somebody record, no? Appreciate so much extra credit for the student que remind me or press the button for record. Thank you so much. Appreciate. The last video I posted in Blackboard, September 8th. September 8th. Now today is September 10th. Okay. You see the board? No?
Yes.
Okay. One more example of the slant asymptote. Suppose this example. Suppose a function I want to call g. And the function is 2x squared minus 5x minus 3 divided by x minus 2. And my first question is, we have a slant or no?
Yes.
She said yes. Why? Explain me why.
Because you only have the degree on the denominator is 1 and the degree on the numerator is 2. So you have one more.
Super. This is the reason. Very, very well. And my second is where? Well, to do that, I need to perform a long division or synthetic division. What do you prefer? In this case, possibly doing both or no? Synthetic or long division? Long division or synthetic division? It's possible doing both or only one? What is the restriction? Okay, what is easier? Synthetic or in your opinion? Both are complicated?
No.
Synthetic is easy, no? Synthetic is easy, in my opinion, no? In your opinion, no? Yes or no?
It's okay.
It's okay, she says it's okay. Okay.
I wouldn't go as far as saying easy, but it's okay.
Okay. Okay, let's do it in both ways. Let's do it using long division first. And long division is possible always, I'm saying that is possible only when the degree of the denominator is 1. In this case, it's 1. It's good. Entonces you copy 2x squared minus 5x minus 3 divided by x minus 2. Entonces we have 2x, no? Because 2x times x is 2x squared. And 2 and negative 2 and negative 4x. By subtracting, change the sign, 0, and this is negative 1, negative 1x. Bring down 3. Now is negative 1, because negative 1 times x is negative x. And negative 1 and negative 2 is positive 2. By subtracting, change the sign, this is positive, this is negative. So we have, this is cancel out, 0, and this is negative 5. But I don't care the remainder. I care the important information for me now is this. The slang is y equal to x minus 1. And this is the answer I need. Let's do it by synthetic curiosity. And the test you select either way. 2, negative 5, and negative 3. This is x0, this is x1, this is x2. And you divide by 2 positive, because it's negative in the binomial, but it's 2 here. Bring down 2. 2 times 2 is 4, negative 1. Negative 1 times 2 is negative 2. This is negative 5. And this negative 5 is exactly the same as this negative 5. And this is x0, and this is x1. And the formula is y equal to 2x minus 1, because x to the 0. Same answer. Very good. Very good. Okay. Entonces, this is, we finish now, theoretical part. We go to the example, but not today. Entonces, now I want to enumerate the guideline to do the graphic of the rational expression. So for graphing a rational expression, this is very complicated. For rational function, you need to following this step one by one in the same order. Step 1. Okay, the step 1 is they are polynomial with no common factor. So you need to guarantee the polynomials are they. Who is they? The polynomial PQ are polynomial with no common factor. In few words, the first thing you should do is factorization the polynomial on the top. Suppose x minus 2, x minus 3, x minus 4. The polynomial in the bottom, x minus 2, x minus 5, x plus 1. And you cancel out the common factor. Okay, this is the first step. And you know that the factor is gone is a hole. You consider like a hole in the graph. Maybe sometimes happen that we have no hole because there are no common factors. Okay, no problem. Okay, but this is the first step. Everyone follow me? The second is find the y-intercept. This is super easy. And you, using function notation, you evaluate 0. Okay, this is a formula to find. We're using this formula always for finding the y-intercept. You plug in 0 into you replace x for 0, and you get directly the value for the y-intercept. Number 3 is find the x-intercept. And the x-intercept, the formula is f of x equal to 0. So the 0 is now in the x value, in the y value here. But specifically in the rational expression, okay, is p of x divided by q of x equal to 0. F of x is p divided by q. It's important to understand that the bottom part do not participate in this game. You take only the numerator part equal to 0, and that's it. This is equivalent specifically in the rational function p of x equal to 0. It's equivalent. Forget about q. Q is not important. Everyone follow me?
Yes.
Also, number 4, extremely important, is determine vertical asymptote in this order. What is the formula to determine vertical asymptote? After the simplification, any common factor, this factor is gone, it's gone, it's gone, it's a whole. The factor stay in the denominator part equal to 0. So the formula is you take q of x, is the polynomial in the bottom, equal to 0. And you solving this equation, and the answer for this equation, in this case, suppose in this example, this elementary example I copy here, is 5 and -1. Look, 5 positive, opposite sign, and -1. This is the vertical. In conclusion, vertical asymptote is easy because you need to find the 0 of the polynomial in the denominator after the simplification of the wholes. Okay? Number 5. Number 5 is determine the horizontal asymptote or a slant asymptote. Why we work in both? Because they are mutually exclusive. Si we have horizontal, we have no slant. Si we have a slant, we have no horizontal. And remember, determine the horizontal and slant is the rule of the degree. You analyze degree, I don't want to repeat it now, degree P and degree Q. Same degree, horizontal. Degree of Q bigger than P, horizontal special. Degree de P greater than 1, degree Q, slant. Super. Number 6. I almost finished, guys. Number 6 is determine symmetry. Very important symmetry. Because you determine symmetry, you save time. You determine if the function is even or it's odd, or it's neither. The formula is si f of x, f minus x is equal to f of x, the function is even. I want to explain detail next time. If the function in minus x is equal to minus f of x, it's odd. Otherwise, it's neither. And finally, always you determine additional point. Plot additional points. How many points? I want to explain the technique to selection, to pick how many points you need, depending on the problem. No? There are no rule, depending on the problem, but I want to explain it. So next time, we are doing completely 1, 2, 3, maybe 4 examples of the do everything from the beginning. Domain, intersect, asymptote, symmetry, additional point, and we are using decimals to see everything. By the way, you create account in decimal or not yet? You believe you don't need that?
I did it.
Okay, super. One more thing, maybe you like. Let me know if you like. I can send to you by email the link connected with my decimals demonstration. Exactly the same I show you here from the sky. And you see the link, and when you click, you open. You open, it's yours. Maybe you change something, but my decimal stay the same. Now I offer to you free these decimals. Okay, this link is connected with my decimals. And you want erase, delete, it's yours. You manipulate if you want. Do you like?
Yes, sir. Very much so.
I will send right now after the class. I want
Thank
to
you.
link. Okay, pleasure, guy. Nice. Always, I enjoy working with you. Excellent students. I suppose everyone, as soon as possible, working in the homework